Hello guys, let's solve this question today, reverse linked list. So you're given the head of a single linked list, reverse the list and return the reversed linked list. So what you're basically going to have to do is to reverse this. So make 5 the head, followed by 4, 3, 2, 1, just like this one. So you reverse it. So you take this arrow, reverse it. So let's look at how to plan and solve this one. So what you basically have to do is to reverse the arrows. So you take this arrow, make it point back, make this point back as well. This should point back, this point back as well. So make all of them point back. So the simple thing to do here is to, let me redraw it so you see it well. So this is how it is. So now we have 5 residing here. We have 4 sitting here, 3, 2, and then 1. So the arrows are initially pointing here, right? The arrows are pointing to this direction. So, and then here is what we call now, because there's nothing here, no node, nothing at all. So what you do is we take the next point at that point here and then point it backwards like this to point to now. We take the one that points here to point backwards. The one that points here must also point backwards. So that's basically what you're doing. So after that, then we are basically done. So let's initiate 2 pointers and call one of them current pointer. CURR. And let it point to the current head. We call it current pointer. And let it point to the current head. Then initiate another pointer called previous and make it point to now, beyond the list now. And then what you do is you take this arrow, like this next pointer here, then you reverse it, you make it point back, you turn it into this. And then you update the current pointer to 2. And then the previous pointer, which was now, you update it to 1. So now what you do is your current pointer will point in here. Your current pointer. And then your previous pointer will be pointing here. Prev, P-R-E-V. And then you take this pointer, you point it backwards. And then your current pointer will now be updated to this place. See, your current pointer will be here. And then your previous pointer will now be pointing to where the current was. After that, then you update the current pointer. And then, so as the current pointer moves, the previous pointer follows. That's exactly what you're going to do here. So let's look at the code. It's actually pretty simple. So our previous pointer is equal to none right here. Then our current pointer points to the current head. So head. So now we start a while loop while current is still in range. What we do is let's create a next node. Next node is equal to current next. So what this line is doing is that once we first take this link and reverse it, we lose track to the remainder of the nodes. We lose track to from 2, 3, 4, 5. We lose track to everything because you look at it, we take this arrow, we reverse it. So nothing is connecting these two again. So we need to first store the remainder of the nodes from 2 to 5 inside something. And that's why we are storing inside the next node. So that after reversing this, we can still have access to this whenever we want to use it. So that's what we are doing here. So now next node points is like from 2 going. So now let's go ahead and do it. So now let's actually do the reversal. So now let's take current next and point it to previous. So we are taking it, instead of it pointing here, we are pointing it backwards. So this is how you do that. So you let current dot next point to previous. Yeah. So this current, its next is 2. So instead of letting it point to 2, you say no, point to previous, point backwards to now. You do that. And then once you move current to this place, you do the same thing. Instead of letting it point in here, you let it point to previous. Because at that time, previous will be pointing here. And then you move to 3. Current is now pointing to 3. Instead of letting it point to 4, you reverse it, let it point to previous instead. So you reverse everything. And you are in a loop. So it will continue to do that until everything is finished. So we just do it once because it's in a loop to continue to do that. So now this is the main meat of the problem. This is a reverser. This is what actually does the reverser for us. So now what you have to do is update the previous pointer to point to current position, and then let current also move forward. So previous pointer is now current. So we move previous pointer forward, and then the current must also move forward, right? So current is equal to current dot next. That's what it's supposed to be. But remember, we stored current dot next inside next node. So instead of current dot next, we put next node there. And let me see, 1, 2. So I think we're basically done with the code. So we just return previous. Remember, we move previous to where current is. So both of them will be at the same place. And then we move current forward. And then after we reverse this, we move previous to point to come to where current is. And then we move current forward. So at the end, previous is going to be pointing to the last node, which is now the head, which is now the first node, because it's now the head. So previous will be pointing to that. So we just return previous and we are done. So this is basically the whole code. It's pretty simple. Let's try it and see if it's going to work. Hopefully. So now it works. Let's submit it and see if it's going to pass all the test cases. So it does pass all the test cases and it's pretty efficient. Yeah. Let's analyze the time complexity. So right now, we set a while loop. We go through all the nodes, 1, 2, 3, 4, 5. So we go through everything and reverse it. So time complexity is just gonna be O of n. For space complexity, we just use previous pointer and current pointer. So they're just constant. So for time complexity is On, but for space complexity, it's big O of 1. So this is time complexity, and this is space complexity. Space. So this is basically it. So thank you for watching the video. If you like it, you can consider subscribing so that next time you don't miss other important videos, and visit the channel frequently to see updates. All right. Thank you so much. All right.